why Kubernetes cost management matters now more than ever. What are the different nuances which are involved? What are the things that you need to understand? Where does the money come from, right? How is your Kubernetes cluster divided in such a way that is incurring cost for you? So this is something that we'll be talking about in this particular webinar, which is gonna set a strong foundation for other webinars that we are gonna do. But just to quickly start with something interesting, I would love to show you all this particular interesting statistics. Okay, so when we talk about Kubernetes cost management, right, this is a pretty interesting statistic by Sysdig, which shows that out of all the resources that you have provisioned, 69% of the CPU resources go unused, right? That's a really huge number. So you can think it that way, that out of all the resources that you have provisioned, 69% of the resources are you are not actually using those, but you're paying for that at the end, right? So this is a good way to get started to understand why this topic is so important, right? But apart from this, what I feel is increase in the adoption, increase in because Kubernetes adoption has been increased a lot since the recent years, right? According to one of the reports of CNCF, 84% of people of organizations using Kubernetes have increased throughout these past 3 years, which is a really huge number. And I feel that when adoption increases, infrastructure becomes more and more complex, and it becomes more and more complex to manage that infrastructure. And because of that, because we are all humans, because DevOps engineers, platform engineers are all humans, there are certain inefficiencies in the infrastructure which costs more, and you end up seeing that huge bill at the end of the day, right? So, Rajit, I think to quickly start off with the discussion, the question I would like to ask you is, according to you, what's causing this surge in Kubernetes cost recently, and why do you think it has become difficult to manage cost at scale? I think we can talk about one from the perspective of an organization itself, right, who are seeing the bills at the end of each month or at the end of each year. But I think it's also important to talk about from the perspective of a DevOps engineer as well, because those are the ones who are actually managing the infrastructure, right? So let's touch upon this point first.
Okay, awesome. I think you already highlighted one statistic, and I want to go back to that same statistic, which is out in a security report to explain what the sort of potential for cost saving. This actually jives with what we've seen during consulting engagements, and when people started to use our product, the data that we get from that. There's a lot of unused resources, and these are costing a lot of money. And the reason why we are highlighting this, it's like you said, platform engineers, DevOps engineers, they are the custodians of the Kubernetes clusters. They provision clusters, they manage clusters, they take care of clusters. And so I kind of wanted to highlight to them the potential for them to kind of help their organizations to save cost. And then we can chat about some of the pain points and challenges and how we can get there, right? Because at the end of the day, so I actually sympathize with the platform engineers, because on one end they have to kind of keep the applications running, keep the developers happy in lower environments, and at the same time there's a lot of pressure from the management to save cost, right? So what I really want to do here today is to empower and enable our platform engineers, our DevOps engineers, to really understand, what are the potential for saving costs, but at the same time, what are the fundamentals that help them gain that visibility so they can start providing, better cost management strategies to their organization.
That's interesting. So in the stat that you have shown here, right, as I mentioned, 69% of the resources, CPU resources have gone unused, right? And a couple of more statistics. So can you go over a little bit in depth and help us understand, like, why does this matter if you're a DevOps engineer, and why does this matter looking it from the organizational perspective?
Right. Yeah. So if you look at most applications, they are more memory bound and less CPU bound. But when you ask people, they will, if you ask developers, hey, how much CPU memory you need? People will say that, I need X amount. But really, the actual usage, even in our own organization, let's be honest, CPU usage is very low. Most applications are memory bound, and CPU is an expensive resource. Actually, it's more expensive than memory. So that's why this is an important sort of statistic to understand. I've seen a lot of wasted CPU, and then we're beginning to see a lot of wasted GPUs. When we look at the aggregated metrics from our product across the board, that's another one. GPUs are also very, very expensive resource. So those are things that people need to care about. And also, I think the cost savings per number of nodes from smaller organizations to larger organizations, actually, especially in very large organizations, there's lots of potential for cost savings because so many different clusters, different teams, and without having that overall visibility, it's very difficult to figure out where your costs are going, which clusters are inefficient, which workloads are inefficient. So this should kind of give the platform engineers a bit of a wake-up call to say, hey, this is what you're potentially dealing with at your organization. And then let's jump into the next section to kind of break down this and figure out how we can start improving costs.
You talked about inefficiencies, right? And I definitely agree with that point. So, from your experiences in talking with organizations and talking with different teams, what are the different real pain points for engineers that you have seen that could cost you more from an organizational perspective? Maybe we can touch upon that point.
All right, so let me walk you through a couple. Let's look at these pain points. So first one is over provisioning. If you're a developer, you will relate to this, and if you're a platform engineer, you will certainly relate to this, right? If you ask any developer what's their solve, they'll like. If you ask them, they'll like, how much CPU and memory? I can, as much as I can get, right? And that's also because people are afraid of performance issues. People are afraid of the applications not performing, so they err on the side of caution and end up giving more. There's another aspect to it. So a lot of organizations have right sizing guidelines, mostly t-shirt sizing, right? And so people tend to err on the side of caution and pick something a little bit oversized. And if there's no feedback loop and nobody revisits them, now we have a whole bunch of applications taking up resources that they're not necessarily using it, right? So that's important to kind of understand, the developer mentality. We have to sympathize with them, but at the same time, we have to empower them, right? And sometimes also I've noticed, we deal with a lot of observability, right? And when there are production issues, sometimes the standard answer is, what about the CPU usage? What about the memory usage? Have you increased it? But if you have that data, then you can go back, the platform engineers can go back and say, listen, this is what you're seeing right now. That's not the real cause. Because I have seen n number of times that people think that is the answer to the question, right? So they'll increase the number of pods or increase the size. But that's really not the root cause. So very important to understand over provisioning. This is a number one area that you can save. Underutilized clusters. We've seen this over and over. When you break down the cluster cost fundamentals, we'll talk a little bit more in depth in this. But generally, what I'm talking about here is you have a cluster with X amount of capacity, but your workloads are only using a certain percentage. And the idle capacity of that cluster, sometimes I've seen 30, 40, 50%. And you're paying for it. Your cloud, it's reflected in your cloud bill. So reducing that idle capacity is, very important. So I would look at, I will start here, look at what, underutilized clusters, start improving the idle capacity there, then look at the workload cost. This is another problem. I think we already talked about this. Without adequate guardrails, if you don't have some sort of guardrails, platform engineering practices, developers may be able to provision more than they should. And typically organizations handle this with quotas and limit ranges and things like that. We're going to go deep into it in one of the webinars in the future. But this is also a key challenge the platform engineers face, to kind of get the developers to follow the best practices, because that has a direct impact on cost, right? And then finally, dormant workloads. We've seen this a lot in larger organizations where teams are now, platform engineering has empowered people to sometimes spin up clusters. They get their own namespaces where you can do whatever you want. And even if you have limits enforced, like resource quota, sometimes people do test workloads. And then they forget. They don't shut them down, and so now even if you have whether it's Carpenter or cluster auto scale, your cluster is not going to scale back down because some workloads are hugging there, but it's really not doing anything, right? So dormant workloads are a big problem for some very large organizations. Without that visibility, without that oversight, that's just eating up cost for no reason, right? So those are kind of like the main challenges that I've seen.
Very interesting. You mentioned about over provisioned workloads, right? I think at the same time, there's also a problem of under provisioning, right? You, on one hand, you end up you end up provisioning a lot more than what you actually need, but on the other end, you may end up provisioning too little, right? That's also a problem. So I think in that scenario, data driven right sizing is one of the strategies that a lot of organizations are now trying to implement. We covered all the real pain points. According to you, what's the one most prominent one that you have seen that a lot of organizations is a real pain point for a lot of organizations? What's the
I
most
think
prominent one from this?
I think across the board, from startups to very large organizations, I think over provisioning of workloads is the biggest problem. It is usually it's the fear of what if something happens, so people end up over provisioning just to get around, in production. So I would say that's if you're, if you want to remember one thing, that would be the one thing. But also think about the idle capacity in the clusters as well. And in that case, it's generally not the developers, it's the platform engineers worried about, even if you have auto scalings, it takes time to auto scale, whether it's Carpenter is faster, but still you need a little bit of burstable capacity. So always try to, play on the side of caution. So those are, I would say, two things. From a platform engineer's perspective, think about idle capacity. From a developer, DevOps engineer perspective, think about over provisioning. Yes.
Absolutely, yeah. And when we talked about underutilized clusters, right, it's not about what you are actually paying and what you're using, right, because that's how the model works. The problem is that you're paying for what you're not using. So those unused resources, that's the main pain point. And we'll definitely talk about more strategies on how you can optimize so you can reduce that number of unused resources. So I feel that now you would have a good idea of why cost management is important now more than ever to talk about. And we also discuss some of the real pain points that engineers are facing currently. I think, Rajit, it's good to transition now towards talking about cost fundamentals. And in this particular one, we are going to help you understand where exactly is the money coming from. Can you help us understand, like, if I see from a cluster's point of view, how can we break down the cost so that I exactly know where the cost is going?
Right. So if you take a Kubernetes cluster, you can broadly categorize into two parts. One is the cluster asset cost, and one is the cluster overhead cost. The asset cost is the resources you use, whether it is allocated before or usage based, and then the overhead is typically the operational cost. So this could include your control plane cost, the cost of running the team, etc. So let's dive a little bit deeper. um, Now here, if you take the asset cost, there are there's the resource allocation cost. So this is where your compute comes in, storage, compute, other things like load balances, etc. Now, what is important to understand is once this is allocated to your cluster, once that node is added, it starts to incur cost whether you use it or not, right? So that's why kind of highlighted it in red, right? The second part is usage based. So this is network cost, right? Egress, cross zone, cross region. For some customers, this can be for some users, this can be a significant portion of their bill as well. But this is based on usage. So the more you use it, that's only when you get charged. Then at the bottom is the cluster overhead cost. This is your control plane cost. If you're paying any licensing costs, right? Like this is important to understand because when you're thinking about, we'll talk about the number of nodes, etc. This comes into play, right? Like, should I use 4 large nodes or I don't know 8 smaller nodes, right? And the blast radius is higher if you have less number of nodes, but you may be paying a higher licensing cost, because let's say your observability or something is charged on a per host basis, right? So it's kind of important to understand your overhead cost as well, and then balance that with performance and high availability and other things. Other indirect costs, like the cost of running the platform, right? And then you can also in some ways add the cost of common namespaces. So for example, let's say you're running like a monitoring workspace that is shared across the rest of the um, you know workloads, right? That could be typically added into your overhead as well. Think of that as well, right? So these are the sort of like the three things, and you have to understand how your costs are going into these three buckets. Building that awareness will help you to now take measures to monitor, and then take measures to optimize that. So that's the cluster cost breakdown. Shall we now? The next thing is, once you understand the cluster cost, let's dive a little bit deeper into the resource allocation cost. We'll go into the other ones as well. So when you take the resource allocation cost, now this is where it's further divided into two buckets. One is how much it is actually actively used by workloads, and how much it is idle. So if you're a platform engineer, you got to keep an eye on this idle cost, because your idle capacity, every cluster will need some sort of idle capacity, right? So you can't have 100% utilized cluster, right? You need a little bit of breathing space, because even if you have autoscalers, Carpenter, it still takes a little bit of time. So you need to have that breathing space. But if your idle capacity is like 20%, 30%, 40%, 50%, then it's something to think about, right? So that's one area that you can make a big impact right away, without compromising performance if you see a very high idle capacity, right? And if you haven't done any kind of auto scaling, at the least get cluster auto scaler, so that you can take some concrete steps to reduce idle cost. Let's look at actively used by workloads. That portion here also doesn't, even though it's green like this, doesn't necessarily mean it's fully optimized. This is where your over provision workloads will make a difference. The more you right size, the actively used by workloads will start to decrease, right? And that means you can, now your idle capacity will grow, so you can start shrinking the cost. Remember, unless you remove the number of nodes or resize the nodes, you're not saving on the cloud bill. So that's very important to understand. So the two things that will help that is reducing the idle cost and right sizing your workload. So those are the two things to kind of remember in this segment.
A quick question here I have for you, Rajith. We talked about idle capacity, right? And I feel that this can be regarded as one of the hidden costs, which are sort of hidden from the teams who are working. So, according to you, from your experiences, what are the common mistakes or surprises that you have seen teams face when we talk about these hidden costs?
Yes, so I think it mostly comes from either lack of awareness or lack of visibility, or both. So understanding what your idle capacity is kind of important. I mean, at the least, you use Prometheus to see what's going on, right? Like so scrape those metrics, see what is going on. So I think that can help you, build that awareness about the efficiency and the idle capacity. Yes.
So we now know that how are the costs broken at a cluster level, but I think let's take a deep dive and talk about the container cost breakdown. How is the container comprised of, and how is it costing you, and how it adds to the overall bill of a particular cluster?
Right. So when we are trying to right size and reduce the actively used by workloads portion of the big cluster thing, it's good to understand kind of what's happening at the container level, so that we can right size. So if you take a typical container, you giving it some resources, CPU, GPU, in some cases, the memory disk, and that's your allocation cost, and then usage based on actual usage, egress, cross zone, cross region. Now, the reason why I'm kind of highlighting the network cost, I'll give you a quick story. I actually did a LinkedIn post on that. It was a smaller amount, but compared to what we were paying for that cluster, the network cost was more than 15% because we had a Kafka cluster across 3 availability zones. And the majority of the cost came from just cross-zone traffic, because there is a cost associated with cross-zone traffic, right? So it's important to understand that, measure that, and keep that in mind, because most people understand CPU, GPU, and memory, right? Right, you have to right size the container. That's the most fundamental piece. If you right size the container, then you start to right, the trickle effect will help right size the cluster. Now, there's 2 sort of dimensions, so we'll talk a little bit about that as well. You right size the container, and then you right size the number of replicas for it as well. That is very important. And once you understand this, the measuring the we'll actually come to this part first, and then we'll go back. Once you understand how much you are giving in terms of requests and limits, from a container perspective, that will really help you to right size this container. So let's, everybody understands about the limits and requests part. So the limit is what the container or the pod, the container can go up to, and the request is what the Kubernetes system will guarantee you, right? If it can fulfill the request, the workload will not get scheduled, right? Now, what we often see is that the usage is actually lower than the request, right? And that's where the efficiency calculation comes in. If your efficiency is low, then there's some, like efficiency, like say 30%, 40%, 50%, 60%, something to think about, right? If your workload is constantly breaching the limit, getting close to the limit, then it's a different story. You need to upsize it. But majority of the workloads that we've seen, based on the numbers that we see from our cost management solution, usage is less than request. The consequence here is, remember I said, like, Kubernetes will try to get you that, right? Otherwise, your workload will not, your pod will not get scheduled. So what that means is, if you don't have capacity in the cluster, you have idle, cluster autoscaler setup or carpenter setup, then the cluster will scale up. Now you're actually incurring cost, and your workload is not using that, or you're actually taking up space from some other application that actually may need extra resources, right? So very important to keep this metric in mind. So if there's one thing you're going to measure at the workload level, look at how efficient your workload is, right? And you would find a lot of the times people fairly okay with memory, but pretty poor when it comes to CPU. I've seen 5%, 10%, 1% CPU, efficiency, because people give very high requests. So it's important to understand. So coming back here, let's explain a little bit further here. CPU is a compressible resource, right? And memory is non-compressible, meaning that with CPU, you can oversubscribe, but what's going to happen is you will start to get throttled, right? With memory, if you don't have memory and your application starts to consume beyond the limits, you're going to get killed. So that's also kind of important to understand. One thing to remember, look at the efficiency. If your efficiency is low, take action and right size it. If you're worried about variable traffic patterns, you could potentially handle that with limits, because otherwise you're just, and then that also helps the cluster to auto scale properly, right? Otherwise you're gonna just pay for unnecessarily for the resources that you're hogging. Yeah.
One quick takeaway that I got is, at the container level, you need to measure your efficiency, right? That's the one of the most important metrics you need to track in order to see how much is the container actually using, and compare that with how much you are actually have provisioned, right? How much you have allocated, right?
Yes.
I think that's the most important metric to track. Right sizing again fits into this picture as well. You already have a slide of number of replicas, which is one of the ways you can right size. If we can quickly touch on this topic as well, how does the number of pod replicas matter too?
Right. So the second dimension of sort of workload level right sizing is, once you right size your container, you have to think about the number of replicas. If your container is inefficient, you're going to double, you're going to multiply that by the number of replicas, right? So that's the impact it has. For high availability, you have to run at least 2 replicas, kind of like, especially in production, that's kind of like the minimum recommended, best practice. But sometimes you will need to have more. And I've seen sometimes people go with a static pool. At the least, consider using HPA. With CADA, you have a lot more control on how you scale. So always have to think about the number of replicas as well, because if you can, that way you can reduce cost, but at the same time balance performance, because the cluster will auto scale based on the number of replicas. It will start to auto scale when the demand rises, right? So think about not just right sizing the container. Try to figure out what might be the best way for you to figure out the optimal pod count range, right? If you're going beyond the 2 pod limit, think about HPA or CADA, because otherwise you will err on the right, side of caution and give more than you need. So this is an important one to think about as well.
Rajat, I think we are at a good point now because we now have understood why cost management matters now more than ever. We have also understood how the cost is distributed throughout a Kubernetes cluster from a cluster's perspective and from a container's perspective as well, right? I think we're at a good point to have more visibility. So, what are the major cost drivers, right, in Kubernetes that engineers need to understand? And because I think we are talking about mostly about managed Kubernetes, I think we can talk from that perspective. So maybe you can touch upon that point.
Broadly, the 3 cost drivers are compute, storage, network, right? So let's talk about compute cost, which is what this question is about, right? There's a direct impact based on the number of nodes, the size of the nodes, and the type of the nodes that you use, right? And there are different ways to think about it too. So one is exactly what this gentleman asked: can we use spot instances or preemptible instances, right? There is significant cost savings in using those, but there are trade-offs, right? Some workloads, so your mission critical workloads, you probably don't want to use it, right? So we use some spot instances. So they are great for jobs that like could be like a specific job that can recover. So schedule your jobs, cron job type of stuff, your event driven type of applications that are not super mission critical, that can tolerate disruptions. Because what happens is a spot instance can get cleaned up anytime, right? So if you're running like some important banking type of transaction, you probably don't want to use spot instances, right? But there are plenty of other workloads that can tolerate disruptions. Those are great, and you save a good amount of money on that. The other thing to think about is the type of node, right? So there are, every cloud vendor offers multiple classes of virtual machines. Balanced nodes, memory optimized nodes, CPU optimized nodes, nodes that do well with GPUs, etc. So having different node pools can help. So in that particular case, using node pools and using taints and tolerations, you can do it. So for example, for what this gentleman asked, Navinder, you can use taints and tolerations, so making sure that the workloads that can tolerate disruptions get scheduled in the preemptible nodes or spot instances, and the others get on the on-demand nodes. Or if you have very memory intensive ones, they will get scheduled on the memory intensive nodes, and the others on the like your balance nodes or whatever. Sometimes there's also unexpected costs that come. So we had one instance from our own experience. We can say we used a group of memory intensive memory optimized nodes, but there was CPU was starting to get throttled, right? Because they had low CPU. So you may have hidden performance issues. There's also a cost implication, because in one of the set of nodes that we use, there was burstable CPU capacity. Suddenly there's a line item for extra CPU in our AWS bill. Why? Because the CPU was not enough, so it used that burstable. I forgot the exact type of instance we use. So look at your cloud bill also to understand the impact of the type of node you use, right? So we talked about the type. We talked about the sort of like the size, number of nodes. This is again, it's a trade-off between performance, high availability. So I already mentioned, let's say you can run 4 large nodes or 8 smaller nodes. From a high availability perspective, if one node crashes, your blast radius is small, right? Because only that goes away. But maybe from a licensing cost perspective, it could be higher. So you have to because if you're paying per host, right? Some monitoring tools, including our monitoring tool, it's charged on a per host basis. That's kind of like some of the standard practice out there. So you have to balance between cost and performance and high availability. So all of those are trade-offs. You can't really optimize for every variable. There's a cost of running your business. So you have to think about those aspects as well. The other thing to kind of think about is using variable node sizes. So if you just use cluster autoscale, you will always notice the last node that gets scaled up is always underutilized because it's not, because the node, you can shrink the node size, right? But with Carpent, you can have variable node pool sizes. So it can do better bin packing. And we'll dive into these strategies a little bit more deeper in the follow-up webinar. But those are the ways that you can optimize your compute cost, because that is a significant cost in your Kubernetes cluster. Storage cost, what we normally say is two things. One is people don't pay attention to the class or the type of persistent storage, and the second is massive volumes. People just get large volumes and it's using 10%, 15% of it. Most cloud vendors now allow to dynamically resize. You probably don't want to keep it very close, because your pods will start run out of disk. If you're like a database, let's say you're running a database or Kafka cluster, things like that. But don't oversize it. There are you can definitely resize in most cases, and then also in some other cases you probably need to think about SSD and other things. So a lot of people are running data science workloads these days on Kubernetes, and it can add significant cost if you have very massive persistent volumes provision but not cleaned up after. So unused persistent volumes could be another source of increased cost. So you need to understand the often volumes, unused volumes, and clean up, because once the workload goes away, right? There are other things you can set to for certain workloads, people don't want to set the value to delete it when it's no longer being used, because you need to retain the data. But pay attention to those settings. Some workloads you don't really care. Once it's done, you need to clean up. So unused volumes can be a significant source. Network cost. I already mentioned that this can be a significant source of cost for you. And understanding this breakdown, right? Like for example, if you have a Kafka cluster deployed on a 3 availability zone setup, and you put your brokers on the 3 availability zones, amazing for a high availability. But if the Kafka cluster is very busy, so will the cost start to ramp up, right? Because that the cross zone traffic is charged. Sorry, I forgot the exact cost. Kunal, if you remember, let me know. I believe it's probably 1 cent per gigabyte. I could be wrong, but just double check and let me know. The cost is also, we'll write an article on this as well. It'll be charged from going out of the zone and coming into the zone. You get it charged twice per gigabyte. Pay attention to that if you're running higher, and then if there's a lot of chatter in your cluster, and you have multiple microservices, try to group your more frequently like the microservices that are talking to each other. Try to peg them into a zone. And I know it'll reduce some high availability, but it might reduce your cross zone chatter. That can help you with the cost, because it can be significant depending on the amount of traffic that you're generating, right? Egress cost is what you're serving to your customers outside, and that hopefully it's the if that goes up, it's a good sign for your business, because people are using it and you have adequate mechanisms to kind of tie that to revenue. But egress cost is also something you need to understand and keep an eye on, because you're getting charged for that, right? Cross zone, cross region traffic is usually when you're backing up things to a different region. Like let's say you have a database replication that's for high availability, you're backing up to a region. But understanding that these are the cost drivers is very important. When you look at the cloud bill, sometimes it's a little bit hard to understand, and that's where some of the vendor products are helping. Having this awareness is important, because if you get a big network cost bill, you need to figure out, is it because of egress, is it because of cross zone, is it because of cross region? Then figuring out, okay, which workloads are actually contributing to this. So then you can go, we were able to track it down, and this is coming from the Kafka cloud. Then you can take adequate mechanisms to reduce that, right? Otherwise, it's a bit of a blind spot, a bit of a black box, and you can't optimize the cost, right? Yeah.
We talked a lot about, we started from understanding why cost management is important to talk about today. We then talked about how the cluster is divided and what's the cluster cost breakdown. We understood because that initial visibility is really important. You can't, again, coming back to the code, you can't optimize what you can't see, right? So we saw it from the cluster's perspective. We then saw it from the container's perspective. We understood that one of the most important metrics to see from a container level is efficiency, right? You got to measure efficiency. You need to see how much you're actually using and how much you have requested. Then we moved on to the major cost drivers, right? Network cost, compute cost, and the storage cost. According to you, if you could give us three major takeaways from this particular session that someone can take this knowledge and implement something in their organization, what would those be?
Yes. So first one is, understand your cost drivers for your Kubernetes cluster. Think about the three buckets. Build visibility awareness into these three buckets. So that would be number one, because that will help you build that awareness. Understand and promote this awareness. So platform engineers can also promote this awareness within their teams, giving people, their developers, the engineers, understanding of how the container cost, container level cost breakdown, because right sizing starts here, right? And then efficiency, right? Because the number of replicas will somewhat, like, you can minimize the impact of that if the container is right size. So think about the breakdown and then understand how efficient it is. So even if I break it down just two things on the cluster level, understand the breakdown and the idle capacity, and then here try to figure out how efficient your workloads are. If I'm giving requests, I need to at least get very, very close to that request, if not exceed it, if you can, right? Otherwise, you're unnecessarily paying, and if you see inefficiencies here, this is an important place to keep an eye on. That will help you reduce your cloud bill. So those are the sort of like the three things that I would leave you with. Understanding your cluster cost breakdown, understanding your container cost breakdown, understanding the efficiency of your workloads, your containers. Closing thoughts. Yeah, you can optimize what you don't see. So build that awareness, understand the cost fundamentals, and then at the least use Prometheus. There are tools like OpenCost and there's vendor products, but you should be able to start at least with Prometheus to understand these things that I build that awareness. You'll be surprised how many teams don't even have that basic visibility. Build that awareness, build that visibility. That's a great step compared to most teams out there. Then you can, from there onwards, you can build your cost optimization, cost management practice.